be discussing the counting sort algorithm, and the counting sort overview is counting sort is a non-comparison sorting algorithm that works by counting the occurrences of each element in an array. It finds the maximum element, initializes a counting array, counts the elements, calculates the cumulative counts, places the elements in a sorted array, and finally copies them back to the original array. It has a linear time complexity and is efficient when the range of potential items is smaller than the number of items. However, it requires the additional memory space for the counting array.
Counting sort is a linear time complexity sorting algorithm denoted as 0 times n plus k, where n represents the number of elements in the input array and k is the range of input values, indicating the maximum difference between any two elements in the array. The algorithm operates in three main phases: counting the occurrences of each element, performing a cumulative sum on the count array, and building the sorted output array. The counting and cumulative sum phases contribute to a time complexity of 0 times n plus k, with the dominant term typically being 0 times n in practice. This makes counting sort efficient for situations where the range of input values is relatively small compared to the number of elements, resulting in a linear time complexity.
Real-world simulation. Let's say you work in a library, and your task is to sort a large collection of books based on their publication year. The library has thousands of books, and they are all mixed up. The traditional sorting methods would take a lot of time and effort to sort such a large collection. Here's how you can apply the counting sort algorithm in this scenario. Number 1. Create a counting array. You create an array with a size equal to the range of publication years. For example, if the oldest book was published in 1900s and the newest book in 2023, the size of the counting array would be 124. 2023 minus 1900s plus 1.
2. Count the occurrences. You iterate through all the books and count the occurrences of each publication year. For example, if there are 10 books published in 1990, you would increment a value of n-90 of the counting array. 3. Calculate cumulative counts. You modify the counting array to store the cumulative counts. Each element in the counting array represents the number of books that have a publication year, less than or equal to the index. For example, if the counting array at index 95 has a value of 50, it means that there are 50 books with a publication year less than or equal to 1995.
4. Sort the books. You create a temporary array to store the sorted books starting from the end of the original book collection. You find the publication year of each book and use the counting array to determine its position in the temporary array. You also update the counting array to reflect the position of the next book with the publication year. Number 5. Place the sorted books back. Once you have sorted all the books into the temporary array, you place them back into the original book collection, replacing the unsorted books.